And if you look at the velocity of this comet, it's only because the SOHO satellite has a high enough frame rate to be able to catch this object. If you try to photograph this object with a camera that only took a picture of the sky every few days or something like that, it wouldn't be possible to capture it. And so if you think about the nature of time and you think about the nature of the velocity of these objects, there's many of these objects that elude our sensory apparatus, because our sensory apparatus in a sense are too slow to catch them. And as we get faster and faster cameras, I think what we're going to see as we continue to image the sun is that these types of objects are a lot more common than we had previously expected, and that they actually relate in a more or less one-to-one relationship between the active region on the sun and its particular orbital eccentricity. In other words, it's the incoming velocity, the size of the object, and its trajectory, that whether or not it actually hits the sun or not. And the reason that the modern scientific community has rejected the possibility that these objects are the cause of a coronal mass ejection is because of the active region. It's already there. The active region already exists. The sunspots are already around the area before that object collides with it. And so to understand that symmetry, to understand why that object collides with that space, why it leaves that mark, in a sense, if you want to talk about cause and effect, you're going to have to take time apart. And when you analyze it from a hypertime perspective, you have to consider it all as already kind of already played out. And we're kind of like a needle in a particular groove, watching it from a three-dimensional perspective that isn't necessarily an accurate representation of what it is in a larger dimension. And so this is Astrotometry HD, and it's difficult. It's a difficult movement to wrap your head around. And at that point, the rules, the concepts of cause and effect break down, because at that point the causal chains are two-dimensional. They're multidimensional chains, and what we perceive as the movement of time is intricately related to gravity. And so there's this issue that we have as three-dimensional creatures with our experience of gravitation that relates to the time flow. And this time flow is the mechanism of the magnetic force. In other words, it's the magnetic force that is moving us through time. The magnetic force is actually a symptom of the underlying common carrier wave. And so when you start sorting out what the common carrier of matter and energy actually is, you're working with the actual mechanics of the magnetic force. The reason that the symmetry is there is because the Earth and the comet are coming from the same wave. In other words, the comet, you could imagine the comet as disturbing the waveform that is creating the Earth and creating everything on the Earth, including us, including our eyes. And since this waveform is being disturbed by this comet, the movement of our eyes, the movement of everything on the planet through time is being disturbed. And that disturbance can be observed by looking at what I refer to as the primary time axis, the sun, and looking at the disturbance in the common carrier that is carrying both the comet and us through time. And that relationship is, from a three-dimensional perspective, it just changes the ballgame completely. It just makes it a completely different a playing field. I don't even really know how to approach it. I mean, this is, like I said, I think this is as far as scientific discoveries go, this one I don't even have any reference for it. And it's there to go look at. Look at it if you want. If you want to try to fight against it, you're fighting against reality, and that's your own damage. But this isn't the kind of thing where this isn't like Galileo's discovery. The thing that really separates this from Galileo's discovery is that this, in a sense, challenges science as the sort of church, because the scientific community has adopted this worldview where the Earth is separate. The Earth is this third rock from the sun that is separate from everything else. And this separation is an illusion. It is a very, very, in a sense, primitive illusion from the perspective of any creature that might be more advanced than we are, that has a better understanding of this. And so this is a huge challenge for humanity and for science. And I don't think it's the kind of thing where, like Galileo's discovery, there wasn't a particular implication or application of what he discovered. I mean, obviously, we thought, well, we'll go out and explore the heavens. From what Galileo and Newton were supposing about the nature of gravity and matter, their concept of what it was. We'll go try that. Well, I think we need to step back. I think we need to step back and reevaluate what we're actually going to be doing if we actually cross that ion barrier. Because in astrotometry, the reason that when you get out into what we perceive as the Van Allen belt, this electromagnetic field that surrounds the Earth, the reason that hydrogen starts to ionize is because hydrogen comes together inside of that belt. In other words, there's a frequency relationship between the forms, between the wavelengths of energy that create that hydrogen atom, that are responsible for its properties, that doesn't exist outside of that particular space. And so the Earth is a place where all of this energy comes together. It's a place where all of the energy surrounding it comes together. And that energy is on the outside is constantly changing and undulating. And that is what moves us through time in astrotometry. And so you can't disrespect that relationship if you're actually going to try to travel into outer space and work with what is out there. And I think that this is one of the, as far as the big ticket questions for humanity. If somebody, asked me to answer the Davos question, this would be my answer, is how is humanity going to reconcile its broken worldview on what it is thinking it's going to be doing by going into outer space?